Hello and welcome to helpyourmath.com. My name is Jenna Hirsch, and today we're going to talk about what it means for us to compare and order decimal numbers. Let's start off with when we talk about comparing. When we talk about comparing decimal numbers to each other, we want to figure out which one is bigger, which one is smaller, which ones are equal to each other. So how do we do that? Now, the interesting thing is that comparing decimals really operates the same way as when we compare whole numbers. Let's take a look at it for whole numbers, and then we'll show how it works the same way for decimals. Now, let's say we're comparing two numbers together. Let's say we're comparing this number, and we're comparing this number. And we want to figure out which one of these two numbers are bigger. Well, let's say them first. 4,263, and this number is 4,520. Now, I think some of you can look at this and say, well, I know which number is bigger. I think that 4,520, or I know that 4,520 is bigger, right? And we use this inequality sign over here to show that this number is bigger than this number. A way we can remember this is that this guy over here is like a little Pac-Man, and the Pac-Man's hungry and wants to eat the bigger number, so this number is bigger. Well, why is this number bigger than this number? Well, let's compare them. I'm going to write them in our place value chart over here. 4,263 means we have 4 thousands, 2 hundreds, 6 tens, and 3 ones. And when we're comparing that to 4,520, we have 4 thousands, 5 hundreds, 2 tens, and 0 ones. When you compare numbers, you always look at the biggest place value first, and the biggest place value here are thousands. So you look in the thousands and you say to yourself, well, which one has more thousands? Okay, well, I have 4 thousands here and I have 4 thousands here. So the thousands are the same. So then you go to the next place value, which are the hundreds. Okay, well, let's compare the hundreds because I know we have the same amount of thousands. Well, I have 2 hundreds here. Ooh, I have 5 hundreds here. So that means that this number is bigger. Same amount of thousands, but more hundreds, which is the next highest place value. So that's how we know that 4,520 is larger than 4,263. Okay, well, let's take a look at this now and let's talk about, well, how does this work if we're dealing with decimal numbers? Let's take a look at money. Let's say that I have $13.48 in my pocket, and my friend Sam has $13.29 in his pocket. Well, who has more money, me or Sam? We're going to do the same thing we did before. We're going to write down these decimal numbers in this place value chart and then compare them by place values. So $13.48 means I have 110, 3 ones, there's my decimal, 4 tenths, and 8 hundredths. Okay, so this is how much money I have in my pocket. Sam has in his pocket, I'll write that down here, 110, 3 ones, 2 tenths, and 9 ones. Well, let's compare them. Again, we're going to look at place values. So we're going to start with the highest place value here, which are tens. We both have 110 in our pocket, right? 110 and 110. Let's go to the next place value, which are ones. Well, we both have 3 ones in our pocket. Okay, so we both have the same amount of tens. We both have the same amount of ones. Let's go to the next highest place value, which are tenths. Well, Sam has 2 tenths, 2 dimes, right? Tenths are dimes. And I have 4 tenths. So who has more money? Me. I have more money. And again, when we're comparing this, we're looking at the place values here. Same, same. And so we're going to start at the left because the left represents the highest place value. And then we're going to work our way down gradually to the right. Decimal, tenths. Oop, look at that. I have more. So we're done. So $13.48 is greater than $13.29. Okay, let's take a look at one more example. Let's compare something like 12.50 and 12.5. Let's take a look at these two numbers and let's see which one is bigger. So 12.50 and 12.5, 12 and 50 hundredths, or 12 and 5 tenths. Well, 110, 2 ones, decimal, 5 tenths, 0 hundredths. Okay, interesting. Let's compare that with this number. 1/10, 2 ones, decimal, 5/10. What about the hundredths here? Well, notice that this guy doesn't have any hundredths, right? There's nothing in that place value. If it doesn't have any, you can write a 0 there to represent that. So if we take a look at each one of these place values, and remember, when you compare these numbers, you start at the highest place value, which is tens. We have 1/10 in each one of these. We have 2 ones in each one of these. We have our decimal. We have 5/10 in each one of these, and we have 0 hundredths. Zeros to the right following a decimal don't matter. You can put in a bunch of zeros, or you can just leave it blank. It's the same thing. So it turns out that these two numbers are equal to each other. 12 and 50 hundredths is the same thing as saying 12 and 5/10. We can just tack that 0 on the end over there. Okay, now let's take a look at some examples. So when we talk about comparing decimals, it's best to do it by lining them up according to their place value. So kind of by putting them in a chart similar to this, because then you can really tell. Remember, we talked about the place value to the left represents the biggest place value. Then you can really tell which digit belongs in which place value and then compare them from the left highest to the right smallest. So let's erase this over here. And let's talk about how we can compare these guys. So we're going to use one of the following symbols. We're going to use this, which means greater than. This means less than, or equals for the following examples. So let's take a look at the first example. 0 and 2/10. So this means we have 0 ones and 2/10, 0.2. This next number, 0 and 15 hundredths. Or you can also just call this 15 hundredths, 0.15. Now, if we take a look at these two numbers and we're lining them up according to their place value, they both have 0 ones. We take a look, this number has 2/10. This number has 1/10. So guess which number is bigger? This number is bigger. Now remember, we can also do this. We can tack a 0 in there. And so if you really look at these numbers, it's like you're comparing the numbers 20 and 15. And we all know that 20 is bigger than 15. If you think about it in terms of money in your pocket, here you have 20 cents, here you have 15 cents, and 20 cents is more than 15 cents. So because we have 2/10 here and 1/10 here, we know that 2/10 is bigger than 15 hundredths. Let's take a look at the next example. 0.03 and 0.31. Okay, when we compare these, we both have 0 ones. Here's our decimal. Regarding tenths, we have 0/10 in this one over here, and we have 3/10 here. So we know, because the tenths is the highest place value, that 31 hundredths is going to be greater than 3 hundredths. And if you think about it again, you're comparing the number 31 and 3. We line them up like that, 31 is bigger than 3. Let's take a look at the next example. How can we tell which number is bigger here? Now, instead of using this chart, you don't need to use the chart. I'm just going to show you another way that we can line them up. We can just make sure that when we compare them, we put the decimal in the proper place value, right? So this is 57 thousandths, right? Here's tenths, hundredths, thousandths, so that's 57 thousandths, and this is 1/10. So when we compare them, they both have 0 ones. Remember, we're going to compare them left to right. Here's your decimal. This guy has 0/10, and this one has 1/10. So we know that this is bigger than that. And what you can do, again, you can fill in those zeros over there. And so if you're looking at this, it's like you're comparing the numbers 100 and 57, and we know that 100 is greater than 57. So you would say 57 thousandths is less than 1/10. Okay, let's compare these guys over here. Okay, so 0.035, 0.035, 0.0350, 0.0350. When we go to line these guys up, they both have no ones. They both have no tenths. They both have 3 hundredths. They both have 5 thousandths. They both have 0 10 thousandths. So these two numbers are exactly the same. Remember, you can tack as many zeros onto the right as you want. Just like if we're dealing with a number like 15, we can tack as many zeros to the left that we want, right? Because we know that the number 15 is just 110 and 5 ones. It's no hundreds, it's no thousands, it's no 10,000s. Same thing works with decimals, but that's going to the right. Zeros to the right are unimportant, just like in whole numbers, zeros to the left are unimportant. Let's try one more example here, and then we'll talk about what it means for us to order decimals. So if we're comparing the numbers, and see if we can just look at it this time rather than writing it out like this. If we're comparing the numbers 57 hundredths and 549 thousandths, which one is bigger? Well, they both have tenths. 5 tenths, 5 tenths. Thousandths, here I have 7, here I have 4, done. This guy's bigger. So we know that 57 hundredths is bigger than 549 thousandths. Okay, so now let's talk about what it means for us to order decimals. So that is, if we're comparing more than one decimal, if we have, more than two decimals, if we have a handful of decimals that we want to compare, let's talk about how we can order them. So it's very similar to what we just did. We want to make sure when we're ordering decimals, either from least to greatest or greatest to least, and there's going to be some different words that we can use to describe these, that we line them up according to their place value, determine which one you need first, either the biggest or the smallest, and then list them. And the idea is, and you cross them out as you go along so you don't accidentally list them twice. So we're going to do exactly what we just did before, except instead of comparing two, we're going to be comparing 4, 5, 6, 7 different decimal numbers. Let's take a look at this. This example says express in decreasing order. Now, when we talk about decreasing, that means we're going from biggest to smallest. So we need to look at this list first and figure out what the biggest number is. Let's look at this list and figure out what the biggest number is. First thing that I hope that you notice here is that we have different ones, right? So here we have 9 ones, 9 ones. Here we have 8 ones, 8 ones, and 9 ones. So I'm just going to highlight the 9 ones because we know that if you think about this in terms of money, $9 is going to be more than $8. So these guys are bigger. Okay, so which one of these guys represents the biggest? Well, we all have 9 ones here. Now let's go on to the tenths. Here I have 2 tenths. Here I have 0 tenths. Here I have 1 tenth. What's the biggest? 2 tenths. So the biggest number in here is 9.23. And let's cross that out. Now we have 2 other 9s. What's the next biggest one? Well, now I'm comparing 0 tenths with 1 tenth. And we know that 1 tenth is bigger than 0 tenths. So the next number here is going to be 9 and 19 hundredths. And then the smallest one with 9 as our leading digit is going to be 9 and 5 hundredths. Okay, let's compare the last two. Now these guys both start with an 8. Okay, let's compare these two. We have 8 and 62 hundredths, or 8 and 602 thousandths. Which one's bigger? Well, again, we know that the whole number is the same in both of those. So now let's go move on to the tenths. 6 tenths, 6 tenths. Okay, so they're equal up to the tenths. Now, after tenths comes hundredths. I have 2 hundredths. I have 0 hundredths. Well, what's more? 2 hundredths is more than 0 hundredths. So 8 and 62 hundredths comes next. And then last but not least is 8 and 602 thousandths. And this would be in decreasing order, biggest to smallest. The biggest number here is 9 and 23 hundredths. The smallest number is 8 and 602 thousandths. Well, let's go in the other direction. Let's talk about how we can express, how we can order a bunch of decimal values if we want to order them in increasing order, smallest to biggest. Now let's take a look at these guys and let's see smallest to biggest. The first thing that I notice here, if you're looking at the ones, and that's the biggest place value, right? Because that's the one that's the leftmost place value here. We have 3 in all of these, right? So I have 3.45, 3.0459, 3.5, and 3.4059. So the ones all have the same value, and that is 3. Let's look at the tens now. Let's compare the tens. Well, here I have 4 tens. Here I have 0 tens. Here I have 5 tens. And here I have 4 tens. Well, what's the most amount of tens we have here is 5. So 3 and 5 tenths is my smallest number. Sorry, we're looking from smallest to biggest. Let me rearrange that. So 3 5/10 is the biggest number. So that guy is going to go last because we're expressing an increasing order. We're going to put that guy last. Okay, sorry, let's do this search now. We'll look for the smallest number, put that guy first and figure out where the other two go in between, from smallest to biggest. So regarding the smallest, 3, 3, 3, right? Because they all have 3. Now, this guy has 4 in its tenths. This guy has 0 in its tenths. This guy has 4 in its tenths. So the smallest one there is going to be 3.0459. Okay, biggest number here is 3.5. Smallest number is 3.0459. Let's figure out what two are in between here. Okay, so, all right, we know. Let's go to the next smallest, right? So after 3.0459, what number is going to come next? And then we know what the third number is going to be, whichever one's left. Okay, so when we're comparing these, same ones, same tenths, right? They both have 4 tenths. And now regarding hundredths, this guy has 5 hundredths, this guy has 0 hundredths. So the next smallest one is going to be 3.4059. Okay, and then 3.45. Okay, so in increasing order, in smallest to biggest, the smallest number is 3.0459. 3 ones, 0 tenths, right? If you compare 3 ones, 4 tenths, 3 ones, 4 tenths, 3 ones, 5 tenths. After that is 3.4059. 3 ones, 4 tenths, 0 hundredths. This guy has 3 ones, 4 tenths, and 5 hundredths. So you know that's bigger. And this one has 5 tenths. So we know that's the biggest. And then in between these two is 3 and 45 hundredths. So here is the list in increasing order, smallest to biggest. Here is the list in decreasing order, biggest to smallest. Now, one more kind of interesting property that we can talk about regarding decimals is that for any 2 decimal numbers you give me, I can guarantee to find an infinite amount of decimal numbers between those 2. That is right. You heard what I said. Now, let me explain to you how we can do this. Let's take a look at this example. Find 2 decimal numbers between 1 and 13 hundredths and 1 and 14 hundredths. So what does that mean? Okay, find 2 decimal numbers between 1 and 13 hundredths and 1 and 14 hundredths. Let's do this. Now, remember, that would be, that's the same thing as saying I have 1 1, 1/10, 3 hundredths, and 4 hundredths. Well, what comes between these? We actually have an infinite string of digits that can come after this. We can talk about tenths, hundredths, thousandths, 10,000ths, 100,000ths. So for an example, let me erase this and start again. Just want to give you a little bit more space so you can really picture what it is that's going on here. 1, 3, 1.1 and 14 hundredths. One number that comes between those two is 1.131, right? There's a 1 after that. 1.132, 1.133, 1.134. So as long as these first 2 are the same, right? That 1.13, 1.13, 1.13, or other examples, we could do 1.1301, 1.1302, 1.1304. These numbers are bigger than 1 and 13 hundredths and smaller than 1 and 14 hundredths. So you can find an infinite amount of digits of decimal numbers that are between these 2. Okay, so 2 examples. Let's do this one and this one. Here are 2 examples of decimal numbers that are in between these 2 numbers over here. Okay, I hope that you learned a lot regarding how to order decimal numbers, how to compare decimal numbers, and how to find some other decimal numbers that are between other decimal numbers. Thank you, and I'll see you next time.